I'm up to no good with Threadripper Pro. Seamlessly run Windows applications on Linux with Linux as the host OS. That's Fedora 34 on my Threadripper Pro 3975WX. Here's Microsoft Office. Not only that, this copy of Excel is running inside a different virtual machine than this other copy of Excel. They can't see each other. See how the application is just the window itself and the window controls, like the Windows window controls that you're used to? It looks and works like other Linux applications. This is nothing new. Parallels desktop on the Mac and VirtualBox call this seamless mode. VMware Workstation calls it Unity mode. I kind of like the name seamless. I mean, let's just call it seamless, because it is pretty much seamless. If I want a gaming sandbox, and a sandbox for work, and another different sandbox for my side hustle, and another different sandbox for my personal stuff, like paying bills and financing and banking stuff, like where somebody could actually steal money from me, I can have all these different containers, but use one set of monitors, keyboards, and mice. I can do it all. And I can do it all with seamless video acceleration. Yes, I can do it. Well, okay, there's some bugs, but let's talk about it. You know, I think that basic computer hygiene is going to pretty much require this kind of workflow in the not too distant future, because everybody needs this level of security. Everybody needs this level of data protection because they can separate all their concerns. All right, so how is this working? Remote desktop, actually remote apps, and X-free RDP. You can do this inside LXC now too, since it's repeatable from the command line. At least I mean that you can use LXC from the command line, but we'll talk more about that in a second. There are many ways to run a Windows virtual machine under Linux. I've done a ton of videos on that. That's not a big deal. What is a big deal is that this is a reliable-ish way of doing seamless apps with video acceleration. It's actually worse today than it was 5 to 10 years ago. This is the only real reliable way at present, and yeah, there's some bugs. We'll talk about it, but all of the bugs are fixable, I think. Now, if you know about Wine and Proton and DXVK and VMware Workstation and VirtualBox and VFIO, you can skip to here and see the how-to. Everything today is all about virtualization and containerization. Everyone runs virtual machines for different reasons. This video is mainly aimed at more technical people. I mean, pretty much all my content is, but I want to point out a few things how I think we technical people have failed regular folk from just wanting to run their applications and compute. And we can make the world a better place if we work together. If we recognize the problem, we can take steps to improve the situation. One place that we have failed is making it easy on users to run their applications in kind of an OS agnostic way. A component that we need for that is a good standard that allows us to run hardware accelerated video on both the host machine and a virtual machine without really requiring separate video cards. You can always do it with separate video cards, that's VFIO, but ordinary applications need hardware acceleration for a good user experience, even just drawing boxes on the screen. I mean, you might not realize it, but just basic stuff is video accelerated now. I mean, web browsers, Microsoft Word, pretty much everything relies on the GPU to actually do the rendering instead of CPU. And like I say, modern web browsers, they all use hardware video acceleration just to draw the web page, even a very basic web page. You know, even command line terminals now on Linux, those also leverage video acceleration, hardware accelerated video acceleration, to have a better user experience. Desktop video acceleration in general on Linux really is pretty behind Windows and Mac OS. I mean, Apple forces everybody to change standards because they want it to be a better user experience. Now, to be sure, it's never been better on Linux than it is today, but we've still got work to do. And also Steam on Linux. Yeah. Now, even playing games on Linux, that's better than it's ever been in years. I mean, Steam support and APIs. I mean, many Windows games are actually now playable on Linux because of Herculean efforts by companies like Valve, and they see the value of gaming on Linux. Their efforts working on Windows games and getting them going on Linux, I mean, it's propping up APIs and all sorts of faked Windows-like programming environments on Linux so that you don't have to have a separate video card. DXVK, that's one of the subcomponents that has sort of fallen out of this. It's a real-time DirectX to Vulkan translation layer, Vulkan being a modern, parallel, and good-performing graphics API. Now, DirectX is modern, there's different versions, and DirectX isn't bad, but we've learned something here. Older DirectX games actually perform better with the DXVK than they do with their native DirectX, because it's an older version. There's also Proton Wine by another name, kinda, and Crossover from Codeweavers. These kind of, rose by any other name would smell as sweet. These are all programs that provide more of a program interface equivalent to the Windows environment. Games expect to run on Windows. Wine sort of tries to give them that environment, and Proton and the stuff that Codeweavers do. Now, games are one thing, but what about productivity apps? Well, tellingly, Microsoft Office still doesn't work great on anything except Windows. And your random obscure applications from 1273 AD, yeah, those don't work either. I mean, it's awesome that you can play games meant for Windows on Linux alongside native Linux games, and maybe with no weird side effects. But doing that took a lot of effort. A lot of blood, sweat, and tears went into being able to do that. If you run Windows in a virtual machine, it gives you a much more robust solution. If your application doesn't need video acceleration, install real Windows, and then set up real Microsoft Office. It's going to work. Even 15-year-old Family Tree Maker is going to work just fine, or just about any other program you can think of, because it's not providing Windows APIs, it's not a re-implementation, it's literally Windows. So what's the problem with that? Well, the virtual machine layer, there would still need to be a software driver inside the virtual machine and a software driver on the host operating system to get that accelerated graphics pass-through. I mean, with that, we could pass through a graphics job that's, originates from inside a virtual machine to the host, and it wouldn't conflict with anything that's running on the host. So the host and the guest can share a video application, or can share the video acceleration. One GPU, but shared among virtual machines. If people knew that this was an option, or they knew what they were missing out on, and they knew the benefits, the sandboxing, the security aspect, everything else, I mean, it enables good computing hygiene in general. I think that a lot of people in the market would demand this feature, but the reality is that they don't know that that's an option. Now, in the commercial world, this does actually exist. It's called virtual desktop infrastructure. You remote into a server, and all your apps are there, and they can even run with accelerated video. And you can have one physical piece of hardware that's a GPU-like, and many users can share that for accelerated video. It's a big cost savings, because it's way less hardware. Yes, but also no. The software to be able to do that is crazy expensive. And yeah, it's actually turns out that it's about the same cost, maybe even a little cheaper, to have dedicated hardware for every user. And why is that? Well, the software lock. I mean, VDI is more about security than convenience or cost savings. I'm oversimplifying a little bit, but most VDI installations are all about security. Control the applications, keep the environment safe, protect the data and the intellectual property from theft. These are the main reasons that you see VDI deployed in most commercial environments. It's not a cost savings. It's not, well, it is actually less complex to administer even. It's that same basic computing hygiene, really, that I want for myself. It's locked behind a paywall. For virtual PC or virtual workstation, it's just, the technology is long overdue for trickling down to the masses. I mean, in the beginning, virtual machines was something that only really ran on powerful servers. Now I've got a Threadripper Pro workstation, which is amazing, but also pedestrian. It's attainable. It's not some exotic thing. Why is video acceleration in virtual machines so unattainable in this age, the golden age of computing? All right, so enter VFIO. I want GPU acceleration. We're going to get it done VFIO, or GPU pass-through. We're taking matters into our own hands. All right, fine, I said. Let's just get it done. A second graphics card, we'll pass it through. We'll give that second graphics card to the virtual machine. It'll think it's real. Well, NVIDIA locked that out for almost 10 years. The drivers would exit with error code 43. They're running inside a virtual machine. It didn't tell you that, because it was actually pretty easy to bypass that limitation. I mean, it wouldn't be much of a sandbox if it knew it was a sandbox, right? So you could bypass that, but NVIDIA has seen the light, I think. There's no more code 43 error. Now, to be clear, there's not a software thing for sharing one GPU between a host and a guest with this change. You can do that with commercial GPUs, but not the run-of-the-mill GPUs that we're talking about here. But you can run two graphics cards, one for the host and one for the guest, and you won't get the code 43 error anymore. Now, I picked on NVIDIA a little bit there, but the truth is that AMD has roughly comparable products in their stack as well, and their gaming GPUs don't support this either. But truthfully, I don't think that AMD has the programming resources to be able to do that. I mean, NVIDIA is sort of a juggernaut here. I mean, AMD is doing everything they can to keep up with NVIDIA. I mean, that's a big job. NVIDIA is a juggernaut, and it's amazing that AMD has been able to compete and produce competitive GPUs as well as they have with what they have. There might be a gap here with Intel, like Intel with Xe graphics. I don't know. We'll see. But looking at all this, I really don't know what would actually drive graphics card companies to implement these kind of features. So games work fine in this mode with the GPU pass-through. Think back. All the suffering and torture and pain and misery that all the developers went through to get Proton and DXVK working, and it's still imperfect. Well, instead, wrapping up the entire OS is a way, and not as efficient, granted, and it requires another GPU, but in so doing, you don't have to do any of the other stuff. And out of that, you get the free sandboxing and security and isolation. Now, technically, Windows only outputting to that pass-through GPU, it's a little bit of a problem, because I need a way to switch back and forth my mouse and keyboard to that virtual machine. Maybe I need a second mouse and keyboard that I can pass through to that. It's not really super convenient. You can use a KVM, like the level 1 text KVMs, to swap between outputs on the same computer, but then it's just more hardware, it's not very efficient. Enter Looking Glass. Looking Glass, and I've done videos on this, check those out, is a very fast way of sharing the frame buffer from the guest OS to the host OS. It's been totally reworked and has several contributors now making tons of contributions, making it better all the time. High frame rate and low latency, especially on platforms like Threadripper and Threadripper Pro, work great. I got this dummy plug connected to the system behind me, so I can use Looking Glass pass-through, no problem. Windows Things to Display is connected with the dummy plug connected, because some applications freak out when they don't detect that a display is actually connected to the graphics card. So that's sort of a workaround with that. And then you run Looking Glass on this Windows virtual machine that thinks it's got a monitor attached to it, and then you get 100 FPS and very low latency mouse pass-through. But what about seamless? Can you do that when I'm not gaming? Maybe I want my Windows apps splashed all over my giant mega desktop. Well, I'd need some help from the GPU driver to let me flag and separate the actual windows from the desktop. Where does one window end and the other begin? Do I have two windows that are overlapping? What's handling that? Well, NVIDIA's Quadro GPUs offer this API, and I wish NVIDIA would work with us to incorporate this feature into Looking Glass. They worked with Valve because Steam uses those features for big picture and in-home streaming, even on GeForce cards. Quadro's not required, but us developers at Pleb Tier, what are you going to do? Oracle's VirtualBox used to permit this, but now it doesn't anymore, in case you were typing that in the comments. It's been broken on everything except Windows 7 for years now, and before then it was super buggy. So when you Google something, it's like, oh, you can totally do this. You're wrong. You need the experience. What about VMware Workstation? That shows up in Google searches as if you could use it. No, it doesn't work. It's been broken for years as well. And there are other projects like Cubes OS, which are really cool. They get it, but their project governance sees too much risk in leaking data around the hardware acceleration aspect of this. So they don't want to support things like GPU pass-through on that aspect because it's considered, dangerous. A malicious program could leak data through the GPU. And that's true. That's completely true. But it's also true that I can generate RF interference by turning the RAM on and off really fast and actually generate a Wi-Fi signal that my phone can pick up. That's a thing. To separate out the windows, I need help from the operating system, if not the driver. And it turns out that Windows 10, it's built into the OS. How? Something called Remote App. It's built into Windows. Now, normally this is something that's used with Windows Server, but because Microsoft is all about this one kernel, one whatever, it's there in Windows 10 Pro. You just need to tweak the registry a little bit to get it enabled. Now, Windows 10 Pro still only supports one or two, depending on how you count, remote desktop connections. So that's still a little bit of a limitation, but you can have one process that launches all of your other processes. And separating out the windows is actually handled by the RDP client. I know this sounds a little weird. Remote desktop from this computer, remote desktop from the computer behind me into the computer behind me, that seems weird, but it actually works pretty well. It's pretty straightforward. You don't even have to pass through a GPU if you don't want, If you don't need accelerated video, you don't really have to. But accelerated video does work with remote desktop and compression and different codecs, although you should really check the pull request log at xFreeRDP because some of that stuff is a little broken. So in a nutshell, Windows 10 with a local account and a password and a username and password set. You can create that virtual machine with boxes or QEMU. You can even do it with LXC from the command line, which now supports Windows. Although it's technically not an LXC container, it's a full-fat VM. It's just that the command line utilities will spin up that virtual machine. Once you've got Windows set up, enable Remote Desktop. Next, you need to download Kim Knight's Remote App program. Now, this program manipulates the registry, gives you a nice slick GUI to turn a regular app into a remote app via Remote Desktop, because the app that you want to run as a remote app has to be authorized by the system, which is just a plethora of registry changes. So the remote app thing, it doesn't send the full Windows Remote Desktop. It just sends the application. No start bar, no background, none of that. The problem is that, like I was saying before, you can really only run one application at a time. Well, that's not a deal breaker because you can run Explorer, Windows Explorer, which will let you launch multiple programs, and then that works fine. So you set up Explorer.exe as a remote app, and you connect to that with xFreeRDP. And since remote app is built in on the Windows side, everything actually works really well on the Windows side. It's shockingly good. You can even use this client with other things like an iPad or a laptop or something like that, if you get your virtual machine set up for network access. Oh, and I almost forgot. WhenApps. WhenApps. That's what I want to mention. So WhenApps is another way of approaching the Kim Knight thing, but it's from the Linux side because it creates a registry file. Check that out on the Level 1 forum. That is another way to accomplish something really similar to this. It's basically the same setup on the registry side. And there's also a different xFreeRDP 2 repository because there's bugs. Different bugs, but bugs. Now on the Linux side, setting up the shortcut is easy. I use xFreeRDP because it supports some limited hardware acceleration if you do decide to do the GPU pass-through, although remember it's not required. It'll still work seamlessly, mostly. It's just that sometimes the windows will feel a little bit janky when you drag or resize them or do that kind of thing. xFreeRDP has loads of bugs. It often loses track of my mouse cursor, and it needs a lot of help when I'm dragging things around or rearranging things. I really think that we, the community, need to fund a few $100,000 of development time to really button up xFreeRDP or something. The RDP protocol is pretty good in terms of user experience, at least on every other platform. I mean, I was playing Skyrim on a Surface RT via Remote FX many years ago, so I know that Remote Desktop as a protocol can do this. I also highly recommend AMD 6000 GPUs for these use cases if you're going to use GPU pass-through, because their open source drivers perform really well. The cards can be reset, so that's a good use case for GPUs, and they work really well. One downside is they do not, as far as I can tell, support being shared among multiple LXC containers, whereas NVIDIA cards do. So with NVIDIA, if you're using lightweight Linux containers, you can actually share one GPU among multiple containers. And while LXC supports Windows, as I said before, it's not really a container, it's a virtual machine. So the GPU doesn't pass through. I'm investigating this because there's a couple of things here that make me think that it might work, but it doesn't. I don't know. You're going to have to get subscribed and stay tuned if you want to see that. I don't think that's going to work, at least with that approach. If you just need a trouble-free, seamless Microsoft Office or other app like that and don't mind some of the xFreeRDP jankiness, then there you go. And that's pretty much all there is to it. So be sure to check out my guide, linked below. And remember, your virtual machine doesn't really need a GPU unless you want that GPU acceleration, which to be sure is very nice. It makes things very fast and snappy and responsive. And I just need to get XRDP fixed or put some time in on that. Check out my past videos on SRIOV, NVIDIA's Grid, and even Intel graphics, which brings us an even more modern approach to sharing applications with your GPU, GVTG. Now, with this setup, I can have a gaming VM, and a business VM, and a test VM, and all the sandbox stuff I was saying before. Threadripper and Threadripper Pro make that possible. This is based on the Asus Sage WRX80. I've got a Kioxia NVMe storage array, 512 gigabytes of RAM, and the Threadripper Pro 3975WX, 32 core. One thing I'd love is passing through the start menu seamlessly as well. It's actually probably just some random switch to explorer.exe. I'll probably have figured that out by the time this video goes live, but if you know the trick for that, come to the Level 1 forums and post it as a reply to this how-to guide thing, because that would be nice. I would love to have the start menu at the bottom and the GNOME interface at the top. It's the best of all worlds. That seems like that would be a pretty awesome setup. So, I'm Wendell, this is Level 1. This has been a quick look at seamlessly running your Windows apps under Linux. Sorry to be so verbose, but I didn't know how much you might know. VFIO is for me. I feel like I could have probably gotten a rhyme out of that or something. I'll see you later.